Hello again, everybody. In this video, I'm going to summarize some of the information that we went over in the previous several videos about pointers, and I'm also going to take a look at characters and strings that are also arrays. Is there anything special we need to consider about those when we're dealing with pointers? I'm also going to go through what I call pointer puzzles, where I'm just going to give you some code dealing with pointers, and I'll see if we can figure out what happens with that amount of code. So that'll come up after we do the first part here. So we'll begin with this pretty empty program, and I do have two arrays declared. So there's an array of characters called letters, initialized to the letters A through K. Then I've got an array of strings, which has 5 words in it, and that's initialized to those 5 words that you see there. Whenever we print out the name of an array, then you would expect to get the address of the first element of the array. And that's also still true here, so that's going to work. So we'll do that with just the letters array to prove that it works, and we'll do the same thing with the words array when we get to it down here. I'm also going to go through and print out using the square bracket notation and the pointer notation for each of these arrays. So let's start with the array letters, and let's use the bracket notation in order to print out the contents of the character array letters. And we can put the code in here for that if I click first. So here we have the for loop, and this is exactly the same kind of for loop that I used in earlier videos, where we're just going to print out the array letters using the square bracket notation. And I'll set this up to be a nice little table as before, so I'll print out the string letters, and I'll print out the index, and then we'll do the closing right bracket, and then print out the value, and then finally we'll print out the address of that element of the array. So that's the same thing as we've done before, but let's make sure it works. So we're going to do that now, and then we'll come back and we'll see if we can use the pointer notation to do the same thing. Okay, so now we have the output window, and you can see that we really do get the array printed out. So the address of letters works the same way. If we're just printing out the name of the array, then it gives us the address, and I've converted that again to a base 10 notation, and it prints out as a base 10 number, which helps us to understand it. Easier to read that way. And then we have the actual contents, A through K, in the middle column, and the address is over here on the right-hand side. Now, pay attention to this. Notice the address is only changed by 1 each time, 76, 77, 78, and onward. As I mentioned before, computers now have what we call byte addressable memory. So each byte has an address. And since we can store one character in 1 byte, then we see the address changing by 1 each time. So this is an array of bytes, and each byte is a character, and you can see the addresses, and you can also tell that they're all stored consecutively, as in all arrays. Now let's see if we can output the same information, but we're going to use the pointer notation instead. So I'll put the loop here that will use the pointer notation to go through the array. So this time we are printing out using the notation here, which has the address, and it has the offset K, and then we have the dereferencing operator over here on the left. And don't forget, you have to include that in parentheses. So this now will go through and we'll get the same table, but we'll use pointer notation instead of square bracket notation. So let's compile and run the program. And you can see the output. Here we have in the second group at the bottom, down here, we have the notation of the pointer notation, and we get the same output. So it does work with characters the same way it works with integers that we had seen there, that we saw earlier. All right, now let's move on and let's see if we can do the same thing with strings. We can put the code for that loop here, and I'm going to print out just the name of the array words, which should give us the address of the first element of the array. And then we have the for loop, which looks the same as we did up above, except now we're printing out words instead of the letters. So we just changed the name of the array. Now let's run the program. Oh, one thing else I changed. We only have 5 words, so now K goes from 0 to 4 instead of up to 10 as it did with our letters array. So let's compile and run the program, and we know this will work, so why don't we go ahead and put in the loop that prints this out using pointer notation before we run the program. So we'll go ahead and put the loop here for that. And we still have the same value for k, but this time, and I need to scroll over so you can see it, we will use the pointer notation to go through the array and print out all the words. Now let's compile the program and let's look at the results. I'll bring in the output, and I've scrolled down. We have the other stuff up here at the top, but I'm going to scroll down to the last part where we're working with the array words. So here we go. We do print out the address of the first element of the array, so that works as well here. And then here are the columns. We have the the left column shows the index and the array words. The middle column shows the words that are stored, and then the address is over here on the right. Now notice that the differences between addresses is quite a bit. We go from 24 up to 52, then we go up to 80, and then on from there. And if you did the subtraction, you'll find out that there's 28 between each one of those. So 24 and 28 gives you the 52, and so on. 52 and 28 is 80. And that's because whenever you're dealing with strings, strings are a very special thing. They're not really a basic C++ type. A string is more, it's like a class, and we'll talk about classes later, but it's more than just a regular variable. And the operating system is going to determine how big to make each element of an array of strings. And that can change depending upon how much we want to put in there. If, for example, we wanted to have, instead of an array of words, if we wanted an array of sentences that could be 100 or more characters long, then the operating system would come up with whatever number it needs to set aside, and that would be the number that's used here instead of 28. So it might be 150, it might be 200, it might be more, but that's not consistent. It all depends on the strings that you're dealing with. But you can also see that between each one, it's the same amount. So 28, 24 to 52 is 28, 52 to 80 is 28, and so on. So they are all still stored consecutively, but there will be some padding in here. So, ball only occupies 4 bytes, so the rest of those 24 bytes is going to be padded in some way, probably with just blanks. We can also use the pointer notation as noted in the bottom table. So here we are going to use exactly the same thing. We have the dereferencing operator, and then in parentheses we have the base address of the array, and then the offset 0, 1, 2, 3, or 4. So now I have shown you that you really can use strings and characters in the same way as we have used integers before with pointers. So that works out just fine. Now that we've done that, I want to go over a review of how you can declare pointers and how you can initialize them and how you can initialize the data that they point to. So that's what we're going to do next. In order to keep the screen from getting cluttered, I'm going to just do this a piece at a time. So I'm going to actually end up erasing this information, all of that code, and I'm just going to cut that, and I'm going to insert the other code that I want to show you. Continuing with this example, now you've noticed I've erased a bunch of stuff, and I want to show you, 4 different cases here when you are using pointers and you need to declare them and set them up. So here's case number 1, and this is what we started out with when we just began to look at pointers. So in this case, I have declared pointer underscore un, pointer un, to be a pointer to an unsigned integer. And I'm showing you here something else that you can use instead of the null pointer. Null is also a reserved C++ word. You can use that as well. In fact, this was an earlier version of something you would use to initialize a pointer. And currently, the one that you're really supposed to use is that one, null PTR. But they both work. So whenever you are declaring a pointer, then you can set it to either null or null pointer. And you just use the regular notation. Whatever type it is, you use the asterisk, and then whatever variable you want to use here. All right, now, this did not initialize those pointers. It just declared them, and it set them to null. So currently, they don't really have an address. The address they have is really 0 at this point. So if you wanted to, if you wanted to initialize those, then we needed to have some variables, and we needed to get the address of those variables to store into those pointers. So let's look at how we did that. First of all, let's add some additional variables up here. So I have an array called even that I've used in a previous example. So that's the same as before. And I've got a couple of float variables, pressure and wind. I've got some integer values, up, down, and k. And I have an unsigned integer called left, and I've set it equal to 3. Now we can use those variables to initialize pointer un and pointer int. So let's put the code here, and we can use the address operator to get the address and store that into the pointer. So I'll put the code here. So we have our unsigned integer. Oh, well, okay, I've got a little extra stuff here, so I copied the wrong thing. Let's erase that part right there. And let's erase this part right here. Okay, so you can initialize pointers by getting the address of a variable. So I've declared the pointer up here with pointer un and pointer int. And then I've used the addresses of variables here in order to initialize the pointers. Okay, so they have to be the same type. Pointer un is a pointer to an unsigned integer, and left is an unsigned integer. So those have to match up. Here's the pointer underscore int, and I'm initializing that to the address of down, and down is an integer. So those all match up. So this is one technique that you can use. If you are using pointers, you can declare them, set them to null, and then you can initialize them with addresses of existing variables. Okay, that's one way we did it. Now let's look at another way. So here's another example. And this one, we're going to declare the pointers, and we're going to allocate memory at the same time. So this is probably a more likely way that you would use pointers, because really we don't really need to use variables and have pointers to them as well. We can do that as in one step by using the new. And we did go over how to do that earlier, but let's take a look at how we can do it again. This is kind of a review. So I want to declare a pointer, pointer underscore FL. That's a pointer to a float. And of course it has to be a float over here. We have to use the asterisk there. And here's a pointer to a double. So it's called pointer underscore dub. And when you use the new, then you're allocating space for the pointer, and you're initializing it with the address of that space. So the operating system is going to do that. Whenever you use new, then that's a request to the operating system to allocate space for something. And it's allocating space for a variable that will contain a float, and the address of that location is returned from new, and that's used to initialize that pointer. So this does a couple of things. It allocates the space for the pointer, and it also stores the address of that space into the pointer here. So we don't have to use the address operator. New will take care of that for us. All right, so that's a more likely technique that you would use with pointers. Now let's look at another one. So let's put the code here. And you can also allocate memory, and you can initialize the value of that location. So this is maybe even yet a more useful way to allocate space using pointers than we did up here. You can do a lot of things at once. Here we are declaring the pointer, called pointer1 in this case. It will be a pointer to a float. We will use the new operation to request space, and we will also initialize that space with the number that we have here in parentheses. So this is going to declare the pointer. It's going to allocate space. We get the address for that space to initialize the pointer, and we also initialize what it points to. So that does several things in one step. The others show, the other 3 lines just show 3 more pointers. So here's pointer 2 that points to an integer. So we'll have a new integer, and we'll initialize what it points to be 475. Okay, here's another pointer 3, which is a float. That'll allocate space. We get the address. We'll initialize what it points to 35.5. And then the same thing down here in pointer 4. So here are several ways that you can declare and initialize pointers. And it would be very good for you to remember how to do all of these. You'll use different ones in different circumstances. Now let's move on and let's look at some examples where we're going to manipulate pointers and see if we can figure out what's going on with the result from doing the manipulations. For this first one, and we're getting into the pointer puzzles at this point, let's change some values using pointers. So let's put some code here. I'll paste that in, and let's deal with pointer 1 and pointer 2. So those were set up here. Pointer 1 is a float that contains 3.56. Pointer 2 is an integer that contains 475. Well, if we wanted to change those values, then we just use the dereferencing operator here with an assignment statement, and we can replace what it points to with some new value. To illustrate this, I'm going to print out the values that pointer 1 and pointer 2 point to prior to doing this. Then we're going to reassign values for what pointer 1 points to and for what pointer 2 points to. And then I'll print them out again so that we can see the change. But you can tell from the comments here, pointer 1, it points to 3.56 to begin with. So that statement, that assignment statement, is going to replace the value 3.56 with the value 5816. And similarly, where we have used pointer 2, then pointer 2 contained 475 to begin with, so it's going to change it to 17.25. All right, so I need to fix that. That's not correct here. The value was 475. I need to work on this a little bit because pointer 2, that points to an integer, and I can't set it to 17.25. So you can watch me work on this a little bit here, okay? So 17, so it's going to reset the value of 475 to 17. All right, so that's what's going to happen here. So pointer 2 pointed to a location that contained 475 when we initialized it and declared it. But here we're going to use this assignment statement, and the assignment statement is going to replace the 475 with 17. So note how you use the dereferencing operator with your assignment statement when you want to reset the value that the pointer points to. Now we can compile a program and we can look at those outputs. Here you see the output, and press the D key to continue. That's because I've got a leftover system pause up there that I should have erased. But at any rate, you can see the values that we get. So we have pointer 1 is 3.56 to begin with, and pointer 2 points to 475. So we dereference the pointers, and that's what they point to. So that was what we got when we initialized them up here, 356, 475. Now we change those values for those two lines, and we print out the results again, and you can see now that pointer 1 points to a location that contains 5816. Pointer 2 points to a location that contains 17. So this just shows you how you can use the dereferencing operator in an assignment statement to change the value of whatever the thing is that the pointer is pointing to. Now let's go on and look at a different example. Let's look at this case. Here I'm going to print out whatever pointer FL is pointing to. So we just dereference it and we print out the value here. Then I'm going to reset what it points to the value of wind, and then we'll print it out again. So that's almost the same thing we did up here, except this time I'm using the variable wind. And if we look up at the top, we'll find out that wind is a float, and it's defined here, and it contains 8.2. So that just means that we're going to set the value of pointer FL, the thing it points to 8.2. So that's going to show up here. All right, now let's run the program and make sure that that is working. Here's the output. Now this may be kind of unusual. To begin with, when I print out the value that the pointer is pointing to here, pointer FL, we dereference the pointer and we print out what it points to. Then the value we get is this big thing here. Well, okay, I don't think I initialized it to that value, but let's go see what happened there. When I declare pointer FL, let's go look at that. Where did we do that? Okay, so that's right here. So I had pointer FL as a pointer to a float, and I wanted that to be a new float. but I didn't initialize it to anything. And when you don't initialize your contents and variables in C, then you can assume that you get garbage. So that is essentially what we have here. We have some useless number that was occupying that storage location whenever the operating system allocated it for us to use. But we changed that. So as we scroll down again, let's go back to the code. I set the value that pointer FL points to the value of wind, which we know we looked up and it was 8.2. So now we have initialized the pointer underscore FL. We've initialized what it points to a real number, which is 8.2. Now, let's go on and let's do a little wrinkle to this and put something similar up here. Here's the code that I want to show you. I'll click and paste. So this time, I am going to print out the actual address pointer underscore FL. So I'm not doing a dereferencing, I'm just printing out the name of the pointer, and we know a pointer contains a memory address. So we'll print that out, of course, converted to a base 10 number so we can read it easily. Then look at this line here. Okay, we have pointer FL is equal to the address of wind. Okay, so there's nothing over here, just the name of the pointer, and I set it to the address wind. Then I'm going to print out the address again, and then afterwards I will print out what it points to. Now compare what I'm doing up here to what I'm doing down here. Okay, in the previous one, I just take the value wind and I store that into whatever the pointer is pointing to. In this case, I'm going to take the address of wind and I'm going to put it into the pointer. Then I'm going to print out the new address and I'll print out what it points to. So let's run this program. Now you can see the output. So here we have the output from the first two lines. We had garbage to begin with, and we did reset that to 8.2, but we just used the dereferencing operator and we used the assignment statement to set whatever the pointer is pointing to wind. But the address of the pointer itself, we don't know what that was when we didn't care. But in this second part, I'm going to print out the address. So the actual address that we had for pointer FL, and that was the address given to us by the operating system when we declared it back up here. Where did I do that? Right there. Okay, so that address was given to us by the operating system, and it was the location where this this was the address that a pointer FL contained after we did the new. Boy, that was bad. Let's try that again. When the operating system allocates the space for this pointer FL, then it gave us the address and stored the address in there. All right. Now, when we go down here, I'm going to change that address. I'm going to take the address of wind, and I'm going to go put that in as the contents of my pointer underscore FL. So obviously, pointer FL now is going to point to wind. Up here, it didn't, it was just an address, and we said whatever it's pointing to is going to have the value 8.2, but it did not point to the variable wind. How about that? This one does not point to the variable wind. It just sets the value of pointer FL, the thing it's pointing to, it sets that to 8.2. Down here, I'm going to reset the address pointer underscore FL to the address of wind. Then the pointer FL really does point directly to wind. And then I can dereference that and print it out here. So now let's bring the output back up again, and you can see that. Okay, so when the operating system gives us an address for pointer FL, then that's the address. If you go to that address, you'll find 8.2. Now, I'm going to change the address of pointer FL. I'm going to change it from that to this address here, which is the address of wind. And when I dereference that, then of course I get the value 8.2. But it's in a different memory location. All right, so now this address, 136.30968, that's the address of the variable wind, and of course it contains 8.2. This address up here is 155.11128. It didn't have anything to begin with, but when I assign it this, it assigns it the value 8.2. So those are two different addresses, and those two different addresses contain the value 8.2. Okay? Now, pretty subtle difference in the way it's written. Pretty subtle difference. So look at the way that's done versus the way this is done. So that's why I call this pointer puzzles. Let's look at a few more. Now here's something you might do accidentally. What if we initialize our pointer 1 and pointer FL, and then we have this assignment statement. Pointer 1 is equal to pointer FL. So you know from our pointer arithmetic, we can copy a pointer from one variable to another, one pointer type variable to another. So this is perfectly legal, but now we say nothing points to the value 58.16. Let's go up and look at that. Okay, pointer 1. When I declared pointer 1 up here, then I initialized it to 3.56. So the address where this is stored, the 3.56, that address is saved in pointer 1. Down here, when I do that assignment statement, then address pointer underscore FL goes into pointer 1. Therefore, pointer 1 no longer points to that memory location that contained the value 3.56. I think I got the numbers off again here. Oh, here we go. That's where I did it. I initialized it up here to 3.56, then I changed it right there. Okay, so whatever the case may be, whatever pointer 1 was pointing to, it no longer points there because I overwrote that by setting pointer 1 to pointer float. So now we can show that if we dereference pointer 1 and we dereference pointer FL, that's going to give us the very same number. So let's look at the program. And here is the output. So you can see that if we dereference star pointer 1, then it gives us 8.2. And if we dereference star pointer FL, it also gives us 8.2. But pointer 1 now no longer points to the location that contained 5816. There's no way to get back to that. So this is something that may occur either on purpose or accidentally, but it's a problem actually, because now if you needed to get back to that location, then there's no way. There's no way to get back because you've lost the address. There's no address that's going to take you back to the location containing 5816. So there's some different terminology for that. It's called a memory leak. So now let's look at something else that you can do. So let's look at this line. Do you remember the delete capability, delete function? So whenever you have a new, you can also have a delete. I can delete pointer 3. So maybe I want to, maybe I don't want to. But if I delete pointer 3, then now there's no way to get back to the value 35.5. So up here, when I declared pointer 3, it's a float, and I initialized it to 35.5. So the address was saved into pointer 3. If I delete pointer 3, then there's no way to get back to the value 35.5. So there's a location in memory that contains 35.5, and there's a location in memory that contains 5816, but I don't have the addresses anymore. And there's no way that I can get them because I don't have any variables that are assigned to those locations. So these things are called memory leaks, and it's something you need to be aware of whenever you're coding in C and C++ and other languages that do dynamic memory management. Now let's look at some more examples. So let's declare some new pointers. So here they are. Pointer 5 is a new integer initialized to 3. Okay, pointer 6 is a new unsigned integer initialized to 5. Pointer 7 is a new float initialized to 12.5. And so is pointer 8. Okay, pointer 8 is a float initialized to 37.3. Now let's do a few lines, simple lines of code, and let's manipulate those a little bit. So I'll put that code in here, and let's see what we have. So I have these 4 lines. So the pointer unsigned is going to be equal to pointer 6. So the pointer unsigned was declared up above, and it was just pointing to an unsigned integer. And it doesn't really matter what it was because now we have overwritten it with the address of pointer 6. I am going to assign whatever that pointer points to the value 9. So this is just going to set that address contained by pointer un, whatever that points to will be set to 9. And here's a little calculation. Okay, pointer 8 is equal to star pointer 8 plus 10. So what does that do? Well, this just takes the number that's pointed to by pointer 8, which is 37.3. So if you dereference that, you get 37.3. I'm going to add 10, which will make it 47.3. That new value will be stored into the thing pointed to by pointer 8 here. So we'll just be changing the value from 37.3 to 47.3. Now, the last one is also just a simple addition equation, but it's using pointers and it's using the dereferencing operator. So pointer 7, which used to be 12.5, or when I say that, I mean it points to something called 12.5, then we're going to reset that. So we'll take whatever pointer 8 points to, we'll add on to it whatever pointer FL points to, and that new sum will be stored into whatever pointer 7 points to. Well, we know that that now is 47.3 from here, and pointer FL, wow, what's that? What do we set that to? We need to look back up and find out what that was, and I'll do that when I run the program. But whatever we placed in here, which I think was 8.2, we add that on, and then that sum is stored into pointer 7. Now, you should be able to figure out what those values are. You should be able just to write those down, maybe on a scrap piece of paper or something, and know exactly what's going on here. In order to see it for sure, we have to print out those things. So let's just put some cout statements after that, and we'll print out the values for pointers 5, 6, 7, and 8. That is, what are they pointing to? All right, so is that correct? Yeah, 5, 6, 7, and 8. So we'll see the new values in here. So now let's run the program and let's see what we get. Now we can see the output. So, okay, pointer 5 points to the value 3. All right, so I didn't change anything here. In these lines of code right there, I didn't change pointer 5 at all. So, of course, it is going to remain 3. So we would expect no changes to that. The thing pointed to by pointer 6 is going to be the value 9. All right, so that's what we saw right here. Okay, we used that assignment statement, and we said whatever pointer unsigned points to, that value is going to be changed to 9, just using that assignment statement. So we would expect whatever pointer 6 points to be the value 9. Then we have pointer 8 is equal to whatever pointer 8 was to begin with plus 10. Then we jump down here. I got 8 printed out at the bottom right there. So when we declared pointer 8, we set it to 37.3. Then this assignment statement added 10, and it saved the value here. So, of course, the value we get is 47.3. Then the last thing we had was pointer number 7. We did this calculation. So what do we have here? I didn't print out pointer FL, should have. But if we do the addition, then we have 47.3, and whatever we need to add, which is 8.2, which was correct. We add 8.2 and we get 55.5. So here in this short example, you can see how you can use the dereferencing operators and how you can set the values of things where the pointers point. Okay, so we're not changing the addresses here of unsigned and 8 and 7. We did change the address of pointer unsigned up there by assigning it to pointer 6. At any rate, that is an example then, pretty simple example of how you can manipulate pointers to do some arithmetic. Let's look at another couple of examples. Now this next part, I have some fun with arrays is what I'm calling it. So let's take a look at this. And this is very similar to what you've seen in the previous videos. So I'm just going to set pointer int to the address even. There's an array up here, way up here somewhere. So here's the array even, and it's just set to the even numbers 2 through 20, and it has 10 elements. So we know that even is the address of the first element of the array. And we're printing out some of the same stuff that we did earlier. So if we print out, first of all, we copy the address of even into pointer int, then we can print out the address, we can print out what it points to, which will be that first element, and we can use pointer notation to print out what it points to, like that. But here's something just a little different. What if I do that without any parentheses? What's that line going to give us? Then we've also seen that we can index off of we can use an index or an offset here, and we can dereference the whole thing. So we've seen that one before as well. Okay, well, let's run this and let's see what we get. And what would you expect this to be? Okay, asterisk pointer int plus 1. What value is that going to give us? Now you should know, we should be able to figure that out. But let's run the program and look at the output. Now you can see the output. So we have the beginning of the array even, so we have this address here. And if we dereference that address, of course we get the first element, which is 2. And if we want to take the address of the base address, which is even, we add 1, we get this address here, which you can see, that's 64, that's 60, so it's 4 bytes more. So that's not unusual. But now we come down to this line here. We dereference PRT int, pointer int, and then we add 1. All right. So what that does, it dereferences the first element. So we get the address, and we go to that address, and we get 2. So the first number is 2. Then we add the 1 here, so that gives us 3. So if you want to dereference and use an offset like this, then you have to put that in parentheses. You want to add 1 to the address, then dereference it. So this moves us on to index number 2, and actually second element, index number 1, that gives us 4. So that's the difference. Notice what's going on there. Okay, so you dereference first, get the value, and you add 1 to it. That's different than adding 1 to the address and then dereferencing it. Okay, let's look at the next example. So here we go. Let's put that in. And this looks pretty simple. We only have a few lines. So this time I am going to set this pointer underscore int. I'm going to set it to the address of even subscript number 2. So up here we set the pointer int to the address even, the first element of the array. Here I'm going to set it to index number 2. That'll give us the third element of the array. Then, using that address, I'm going to store the value 7 there. So I'm going to overwrite what was there with 7. So the third element, that's 246, so I'll replace 6 with 7. Then I'm going to print out even and use the square bracket notation 2. So now, let's look at the output from that. Here's the output, and you can see that we really do get the value 7 here. So you can set the address of any element of an array that you want to. Well, I guess you can save it into a pointer. That's what I meant to say. You can get the address of any element of an array that you want, like that, and you can save it, and then you can use that address to do something. So here I'm just using it to reset the value from 6 to 7. Okay, let's try another one. Let's put the code here. And let's adjust the alignment. So this one's a bit more involved. I'm going to have pointer 5. So I used pointer 5 up there, but now I'm just going to reuse it down here. So pointer 5 is going to be equal to even plus 5. Well, you're experts now. You know even is the first address of the array, so if we add 5, that gives us the fifth element of the array. Then I'm going to use that address, and I'm going to reset the contents of that location to 9. So the fifth element was going to be 246810. So now I'm going to reset that to 9. And then I'm going to do a little math, a little pointer arithmetic. I'm going to take pointer 5, and I'm going to subtract 3. So the new value for pointer 5 is going to be pointer 5 minus 3. So that means I'm subtracting 3 words, or 12 bytes. So it's going to move back up. So what index is that going to be now? If this was the same thing as even square bracket 5, and if I subtract 3, then that's going to give me the same thing as the square bracket notation even 2, so the third element of the array. Then let's print those things out. Okay, I reset the value that was pointed to here, which was even plus 5. That's going to be 9. Then I'm going to print that out. So we reset the even square bracket index 5 to 9. I'm going to use the pointer notation in order to print out the value for pointer 5 after it's been reset by subtracting 3. So when I print this out here, it's going to point to the same thing that the second element of the array points to. Okay, so look what happened. We added 5, we reset the value, then we subtracted 3 off of that, and then we just printed out the values here. Now let's look at the output. Now we have the output. And if we look back up a little bit, you can see that we set the even index 2 to 7 before we got down to this part here. So then we set pointer 5 to even plus 5. And when I print that out, well, okay, we did re-establish that reset pointer 5. The thing it points to was to 9. So we did do that. So now you can see, yeah, sure enough, it's 9. So if we do that, print it out using the square bracket notation, we'll see it's 9. Then we subtracted off 3 from the pointer. That's going to move us back up to the second element. So when I dereference it here, then I have subtracted off 3 indices. So now it's back to 7 again. So I've gone back to that index. And just to prove it that the index number 2 is where the 7 is, I print that back out again here. So I'm just doing some manipulations, some arithmetic with the pointers and hoping you can keep up with what's going on. So you should be able to follow this. All right, I've got one final example to show you. Here's the code that goes with that example. And I'm going to use pointer 8. I'm going to set pointer 8 to the address of the variable wind. Then I'm just going to dereference it and print it out, and the value of wind is 8.2. Then I'm going to print out the address of the pointer. So we use the address operator, and we'll print out the address of the pointer itself. And then look at these last two lines. I'm going to print out the address of the star, or the star to the address. So I'll come back and talk about this, but let's go ahead and run the program and look at the output first. This is a pointer puzzle, certainly, isn't it? I've got two operators combined, one next to each other. The ampersand followed by the asterisk, and the asterisk followed by the ampersand. So let's compile the program and look at the output. Now let's look at the output. Now, one thing I added since the last time I spoke to you was I wanted to output the address of wind as well. All right, so I'm going to print out, I'm going to set the pointer 8 to the address of wind, and then I'm going to print out all those things. So now let's go through them. So here's the output from that. Well, we know that pointer 8, if we dereference it, then it just points to wind, and wind contains 8.2. The address of wind in this run is that number there, 592 at the end. Then the address of pointer 8 is this address here. So pointer 8 that's a variable that contains a memory address, but the pointer itself is located at this address here. The address that it contains, of course, is going to be this one. So that's what pointer 8 contains. This is the address where pointer 8 is stored in memory. Now let's look at these odd things down here. Let's start with this one. Okay, just look at that part. If I get the address of pointer 8, then the address that I'm going to get is the address shown up here. Okay, so that's the first part of it. If I take that address, then I dereference it there, then what do I get? Okay, so I take the address first, which is that address. That address contains the address of wind. So when I dereference it, I get the address of wind. Okay, same thing up here. Now let's look at the other way to go about this. Okay, forget about that to begin with. Let's just look at the asterisk and we dereference pointer 8. Well, if I dereference pointer 8, then that's the address of wind up here, right? So, so that is what I get for wind. Okay, if I dereference pointer 8, then that gives me wind, and that's where wind lives. But then if I take the address of wind, then I get that address, right? So these turn out to be the same thing. Okay, so if I dereference what the pointer is pointing to, then it's going to give me wind. And if I take the address of wind by using the address operator, then I get the address of wind here. So either way you do that, either that or if you do this, they both end up being the address of wind. Okay, so that's one of my favorite little pointer puzzles, that you can do that and it's the same thing as doing that. So that's pretty neat. Alrighty, well, I think I've tortured you enough with all these variations with pointers. This video is going far too long, so I apologize for it being 43 minutes already. But at any rate, that's going to pretty much sum up our initial foray into what pointers are. And we're going to come back later, and when we start talking about structures and more involved things like objects, then we're going to see pointers show up again, and that's when they're really going to be important. So anyway, that's all for now. So let's terminate the video here.